Let's now take another look at complex numbers to realize that can be expressed in a different way as we expressed so far. So I have here another general complex number, z. It is represented both by x and y, the real part and the complex part. But as you already know, you can also look at this and see here r as the distance from the origin to that point. And you can see this angle over here, theta, okay, which is basically the anti-clockwise angle that this line over here makes with the real part, okay? We can express then any complex numbers by these two parameters then. Whatever z may be, you can express it by the value of r and the value of theta. R is going to be called the modulus of the number. I wrote here function, this is supposed to be number. I have to correct that, okay? The modulus of z. The second one is called the principal argument of the number, represented by r of z. So don't forget, this must be a number, okay? A real number, a positive real number is a distance. And this will always be an angle that must be, by definition, between minus pi and pi. More on that later. This also means that if you have whichever argument of a complex number, if you add to pi, you'll end up in the same place, so it's still the argument of that number. So how do you calculate the value of r and the value of theta, knowing the values of x and y? Well, the value of r is simple. You just can see here a rectangle triangle, right? This is the hypotenuse, so it's the square root of x squared plus y squared. What about the value of theta? Again, you use the fact that this is a rectangle triangle, right? You have here the opposite side and the adjacent side. The opposite side is y, the adjacent side is x. So let's first think of how can you express y in terms of r and theta and x in terms of r and theta. Well, y is just going to be this times the sine of the angle, right? And x is just going to be this, the r, times the cosine of the angle. Sine for the opposite, cosine for the adjacent. So you have y over x, the trigonometric ratio, which is going to be the tangent of theta. Now, you have a very important thing to pay attention to in this case. If you just go ahead and do this in your calculator, you would have the calculator would give you the results in terms of the principal values for the function tan, okay, which you are supposed to know since last year, is in between minus pi over 2 and pi over 2, and not between minus pi and pi, as you are required here. You don't have a problem if the angle is within the first quadrant and the fourth quadrant. I put this too big. Let me put it smaller again. Again, if you divide the plane in 4 quadrants, this is the first, second, third, and fourth. The first and the fourth, they are already between minus pi over 2 and pi over 2, so we don't have to worry about that. How do you know where the complex number is? Just look at the real part and the imaginary part. First quadrant, real part and imaginary part, they are both positive. Fourth quadrant, real part is positive, imaginary part is negative, okay? So in any of those two, you don't have to worry about what I'm going to say again next. But if the number is in the second quadrant, in which the real part is negative and the imaginary part is positive, or if the number is in the third quadrant, in which both the imaginary and the real part are negative, then you have to do a small trick. Let's start with a situation in which the number is in the second quadrant, okay? So if you would just go ahead and do in your calculator this, the result would be on the fourth quadrant, right? Again, between minus pi over 2 and pi over 2 is all that your calculator gives. But what you want is actually this over here. So what you have to do, you have to add pi. For the second quadrant, add pi. And you are where you need to be. Now, if the number is over here, the calculator will give you a value over there on the first quadrant. So what you have to do, you have now to subtract pi. You subtract pi to whichever this is, and the value will still be between minus pi and pi. So for second quadrant, add pi. For the third quadrant, subtract pi. Okay? Pay attention to these tiny details. By the way, let me make a parenthesis to talk about this chapter as a whole. I would say that the difficulty of this chapter lies on these tiny details that you need to be aware all the time. Okay? None of this is hard to understand, but you need to be paying attention to all of these things. Okay? How do you do that? Solving questions. That's the solution to all the problems in math. All right. We now know how to express z in another way. X is going to be r cosine of theta, as we saw before, and y is going to be r sine of theta. So we can go ahead and write this. But we have here two terms with one common part, which is r, which you can factorize. Okay? So we can write a complex number z as r, open brackets, cosine of theta plus sine of theta I. Okay? If you have a complex number written like this, we will say that it is written in the polar form. The only two parameters are just going to be r and theta, the modulus and the argument. Never forget where this comes from. This times that is the real part. Let me show yes, it's over here. Is the real part, is x, and this times that is the imaginary part. All right? Always keep in the back in your head the link between what you are seeing as a complex number in the polar form and a complex number written in a normal form. Okay? They mean the same thing but using different parameters. For the normal form is the component in the real part and the imaginary part. For the polar form is the distance to the origin and the argument, the angle that it makes with the real part. Okay? The clockwise angle. Now, let's pay attention to another detail. The values of r and these numbers over here, the cosines, they all must be positive. If you see something in which either r or one of these or any combination of this is not positive, you have to turn it into a positive number. How do you do that? You use the symmetry rules that you learn in Math AS. I reproduce them over here, and I'm going to explain using every single combination that you may have. So let's say that you have this number. This is not written in the polar form because the modulus is negative. The cosine and the sine, they are both positive, so that's fine there, but this is negative. So what you have to do, you have to get rid of this minus by multiplying the whole thing by minus 1. All right? So minus minus becomes plus, but now you are changing that. The cosine is now negative, and the sine is also negative. So which one of these rules can you use? The problem is that both cosine and sine are negative. So what is the one in which this happens? Is this one over here. Cosine negative, sine negative. By the way, you look at this in lines, okay? Combine, okay? You use either this, or this, or this. No, you cannot cross them, okay? So both cosine and sine, they are negative. So what you have to do to the value of alpha, subtract by pi. So this will become 2 cosine of alpha minus pi plus I sine of alpha minus pi. Positive, positive, positive. Check. Now the situation. The modulus is negative, and now it is the sine that is negative. The cosine is positive. So the first thing to do is to get rid of the negative on the modulus. That's always where you start with. So multiply by minus 1. Now you are turning this negative, and you are fixing that 1, turning it positive. So your only problem, so to speak, is the fact that the cosine is negative, but the sine is positive. So negative cosine, positive sine is this line over here. So what you have to do pi minus whatever alpha is. And now everything is positive. Last possible situation. Now the modulus is already positive, the cosine is positive, but the sign is negative. So in this case, you don't have to get to multiply anything by -1 because the modulus is already positive. You just have to look straight there. Cosine positive, sine negative. Cosine positive, sine negative. This is the symmetry rule that you use. Instead of writing alpha, just write minus alpha. And you have the problem fixed. Everything is now positive. So again, this is the polar form. The main thing about this is understanding how this translates into the normal, I didn't write it here, the normal way in which a complex number is represented, x plus y squared, okay? How to go from one to the other. Pay attention to the argument in the case, in cases where the complex number lies in the second and the third quadrant, what to do. And what to do whenever you have something that looks like a complex number that looks to be written in the polar form, but it's not, and which symmetry to use in each case.